So this is just a little video to give you some insight as to what's involved with a heat loss survey, a site survey, and system design. I hope you give you a better understanding of why it is a chargeable service and the complexities of what's involved with the data we need to gather. We use a system called HeatPunk, which is a web app. We use the Pro version, which gives us a lot more options. They do have a free version for members of the public to use to give you an idea. We would start with a new project, and you can put in all these details here. And it's important you put in, an address. You don't have to type in the postcode and address. You can use the set from map option, where you can just zoom into a random area. Let's get to this one. And you'll see a little crosshair in the middle of the map. That should be zoomed in enough. It might not be. It is. Okay. And then you get to the pallet section. This is what the fabric of the building is made of. So you will have standard pallets where all the current building regulation U values are listed. So you'll see the U value there is 0.26. For an external wall, we've got all of them for floors, roofs, doors, windows. So that's just a standard pallet to work from. We can add our own fabric information to a custom pallet, but for now, we will go to this stage, and you can start with the ground floor, and it will give you a generic ceiling height that all the rooms will fall to by default. You can change this on a room by room basis, but 2,400 millimeters is a fairly standard roof ceiling height, for British homes. So we'll hit that, and we would go around on a room by room basis and measure out each individual room. And it starts with just a floor plan meters squared, and we will go through. You can drag it to the size you want. I find because it's in millimeters, it's easier just to type it in. So we'll pop that into that room. We'll just do a few rooms as an overview so you get an idea of what's happening. So this room, we will change the room type to a living room, and we can see there's the standard ceiling height. We can change it if we want to. And if you wanted to call your living room something different, because we get plans from architects quite frequently, and this might be called a family room, and it's much easier to call it what the customer knows it as. So when they're referencing the heat loss report, they know which room we're talking about. You can see here the standard air changes and room temperature. And that is dictated by the year of the property. This is just a made up address. I don't know where that is. This is just me randomly zooming on a map to give you an idea. So we can zoom in and out, pinch to zoom, and we would go through and check that all of these walls on this room are as they should be. So this is designed to a temperature of -2.3 as standard. We can change that, and we will do. And it'll tell you the current U value of that wall. If we want to change it, which we have to for nearly every single job, because every job has its own individual characteristics from years of home modifications. Some buildings are hundreds of years old, and they've had extensions built over various different decades, and they'll have their own. So you may have a solid stone wall that's 400 millimeters thick on one section of the property. You may have a single skinned double brick wall on another section. Then you may have a more modern extension, which is a cavity wall with insulation. So you've got all these different options that are built in. And you can also add your own custom ones. You can build your layers yourself. So if you know it's got an external render and then brick, then a cavity, then a brick, and then plasterboard, you can build it that way. Or as we do, we calculate them ourselves and just add in the U value at the end. And you can add custom ones for any fabric area you like. We would then also have to put in the flooring. So we would drag across the flooring area, and we can say this one is ground beneath us, and you have different options: so solid floors, suspended floors, overhanging floors, and again custom floors. So this one, as standard with the year of the build, is just coming up as saying it's ground, and that's the U value for it. It very rarely is that on a retrofit project, so we'll have to work that out ourselves. And this is where the homeowner's knowledge of their home becomes invaluable. Whilst we're on site and we're taking these measurements, we'll often ask you, do you know if that's a cavity wall? Do you know if this floor has been insulated? And if the answer is no, you don't know, that's fine. We always have to design for the worst case scenario. We would rather overheat your house than underheat your house. So the more details you know, the more accurate we can be. And then from here, we would also add ceiling information. So in a lot of rooms on the first floor, that's very simple because you know it's just going to be a loft space above it. But in loft conversions, you may find that it's a pitched roof, and we have to alter and create a virtual room space. So we might know that the pitch of the room is 2,500 high, but then it slopes down to a meter high. And then you will see the arrow appear that shows where the pitch is. And some rooms are incredibly complex and they'll have multiple angles and pitches. And we have to get this as accurate as we can because it affects the room volume, which also affects your air changes and your heat loss. From here, once we've done this for every single room and every area of your property, we would also actually have to add in, oh, let's just pop a second room in. We would add in doors, so an external door there. Same thing, we can change all the details of that and add in custom doors. We would add windows in. We would go around and measure all your existing radiators and put in the details of what they are and their dimensions. And we'd also make note of the largest available space so that when we design for as low a flow temperature as we possibly can, that demands larger radiators for a larger surface area. We'll make a note of that largest available space. And when it comes to designing, it's always a trade-off between what's the hydronically most efficient system we can put in versus what's suitable for you and your home. You might not want a very, very large radiator, and there's always a trade-off. So we don't always get to put in what's the most efficient system. We get to put in what's the most efficient and least intrusive system for you and your home and your lifestyle. From here, after we've got all the fabric information of the building and built out your floor plan, we would also, oh, we don't have a room name. I just need to change that. We would then have to carry out for a heat pump installation, a sound calculation. This is where we assess the sound that your neighbours are likely to hear from the heat pump itself. So we have to take a measurement from the top edge of the heat pump to your neighbour's nearest habitable window. And we have to do this for planning and MCS compliance. So we will choose how many reflective surfaces there are. We will say where it is, back garden, behind, oh, and the extension that's being built. And then we'll say it's got a partial view. It's 10 meters from your neighbour's habitable window. And it's on under 18 millimeter fence. So we'll confirm that. And at this stage, the software has already done your heat loss calculation for you or for us, and it'll suggest types of heat pumps. And it'll give you details you need for each of the heat pumps. We'll go through and select the rest of the hardware for the system. And we always use Viessmann. Great. And this brings us to an overview page where we can start the system design. Now we have the heat loss. And we can change things such as the system delta T, so the difference between flow and return temperatures. This will give you an overview of our design temperatures, which we can also change. And it gives you an idea of what's per square meters, total heat loss, and whether the heat pump can handle it, your hot water and what your reheat times will be, and whether it's passed the sound assessment. And then I'll also show you any of these rooms in red, the emitters are not putting out enough heat at the given flow temperature. And as I'm moving this slider, you'll see just above it where it says SCOP, you'll see the efficiency of the heat pump gets better as the flow temperature cools. So the cooler we can design your system to run at, the more efficient it's going to be. 45 degrees is often considered the crossover point where they become cheaper to run than a gas boiler. But that does depend on how you use your current system. So the cooler we can run it and design to, the more efficient and the cheaper it'll be to run. And you'll see that as I change the flow temperature, you'll see that room's turned green down the bottom right of the screen. And that's saying, okay, at that flow temperature, that radiator's putting out enough heat to heat that room to 21 degrees. So we do this for each room, and then we find one room that is called the reference room that dictates the flow temperature we can realistically design to. There'll be one room in the property that is limited by the physical space available for the radiator or the underfloor heating loops, how many loops you can get into a space. There's always one room that dictates to the rest of the property. And that takes a little while to figure out and find out which is which. But once we do, we can start planning on the emitter schedule. And we will also have to map out and take into consideration your existing pipe runs. So where they flow to and from in your property, where your hot water cylinder is now versus where it's going to be if you're having it moved, or if you don't have a hot water cylinder at the moment, we need to plan with you where's the best place for that to go. And the same for any underfloor heating that may be going into the property that we're putting in for you, where the underfloor manifolds are going to go. We need to calculate the length of the pipe runs. That will dictate the diameter of the pipe runs, and then see how viable it is to get the correct size in and how to map that around your property with as little disruption to you as possible. And all of this affects the time the installation takes and the cost of the installation. So we need to know all these details before we can give you an accurate idea of cost. We can give a generic estimate based off of the heat loss of your property taken from an EPC certificate, and that's exactly how most free estimates are done. They will give you a very generic quote based off of the meter squared of your property, the estimated heat loss, and a generic flow temperature, often nowadays at 55 degrees, which a heat pump will run fine at, no problem. And in some cases, you don't have a choice, although we've not come across that ourselves yet. But they are deliberately very low on detail to try and draw you in with a cost going, oh, okay, that sounds cheaper. Then the reality sets in after a survey that actually the radiators aren't big enough, or the pipe runs are much longer than initially planned, and the price goes up. So we try and give estimates based on at least half the emitters being changed and being aware that you will likely have to have some pipe work changed. But that's where the full heat loss and site survey comes in. So we'll do our best to be as accurate as we can with an estimate, but a full heat loss survey, site survey, electrical survey, and the system design is what is needed to give you an accurate price. So we'll also need to figure out your current electrical load on a survey. So we will use a piece of equipment to measure how many amps your household draws, and we will ask you, we need to mimic the worst possible day for electrical use. And it's often Christmas Day or sometimes around then, where the oven is on, the hob is on, a microwave may be on, a kettle, music, your heating system's on full blast, somebody may be in the shower, where the electrical demand on the property is absolute highest. And then we will take a reading from that, and we will compare that to your existing incoming cutout fuse size, so that we can report all this data to your district network operator. And that's another series of forms and applications we have to go through once we have this data. And that allows them to know that there's going to be an increased demand in your area and whether your existing supply is adequate to handle the loads of a heat pump. We will then go through as much of this design with you as we possibly can on site, and you will see the effect different size radiators have and their outputs. Discuss with you other options or underfloor heating options if you're considering having that put in, which is very common in extensions. And we will give you either 1 or 2 reports. You'll see on the page now we have option 1. We can say we want to design that to 40 degrees. Option 2, we want to design it to 45 degrees. And we can give you reports on that and discuss them with you and explain the details and exactly what's involved within the installation procedure and how long it'll take. And hopefully this gives you a little bit more of an idea and clarification on why a heat loss survey, site survey and system design is a chargeable service, because it can take anywhere from 1 to 3 days, depending on the size of the property, whether it's an existing property or a newly built property that we're working from floor plans to do the design and heat loss surveys from. Hopefully that just gives you a better, clearer indication of what's involved. And if you're looking to have your heat pump survey done and your heat loss survey done with us, then give us a call or drop us an email. On the website, you'll see the contact details at the bottom of the website, and we can get things booked in and the installation process started.